Hey, I'm Jeff. Nice to meet you all. I was just taking a stroll through the woods. I thought it might be a more lovely environment for the beginning of this talk. It would be great if we could all be together in person, but since we can't, I figure may as well get creative, right? Anyway, the title of this talk is Interactive Documentation at Scale Using MDX and Next.js. A bit of a mouthful, I know. But before we get into the details, let's talk context. I work for a company called HashiCorp that builds a variety of DevOps and infrastructure management tools. You might have heard of Terraform, Vagrant, or Vault. These are all HashiCorp tools. All in all, HashiCorp builds 9 different products. We've got Terraform, Vault, Consul, Nomad, Packer, Vagrant, Waypoint, Boundary, and Sentinel. These products all need documentation. On top of that, we have a lovely team of technical writers that produces learn.hashicorp.com, a tutorials and guides website that includes over 750 guides on how to use HashiCorp products in different situations. These websites are all the same in many ways because they're documentation sites, but they also dramatically differ as far as their content and their scaling needs. For this reason, we need to build on top of a strong but flexible foundation for all of them together. And for us, this foundation is MDX and Next.js. Like my metaphor? All right, let's keep walking. I'm assuming you all know what Next.js is being here at the conference, but I want to talk about MDX for a second in case anybody isn't familiar. MDX is a really great open source project that allows you to use Markdown alongside React components that you can just put in line. It's a project that's built by the team behind Unified. Unified is a collective of different really interesting and cool parsers, and they are a completely community-funded project, so you should definitely check them out, and if you're using any of their tools, consider sponsoring them. Anyway, let's stop here for a moment and look at an example of what MDX actually looks like. So here it is. As you can see, it's just Markdown, and then you can use React components in line. That's pretty much it. Let's keep walking. We chose MDX at HashiCorp for a few reasons. First, our engineers and technical writers love using GitHub and Markdown to author content. Product engineers will make updates to the code, and as part of the same pull request, will update the documentation. And GitHub provides a familiar environment that enables collaboration and review on changes to content. It's all part of the same system as a simple pull request. But we knew that over time, as HashiCorp grew as a company, pure Markdown wouldn't be enough to keep up with what we needed from our documentation websites. We already had a library of shared React components that we use across HashiCorp's websites, and we dreaded a situation where we kept extending Markdown with custom syntax and custom JavaScript loaders until it became a language of its own. This would be difficult to maintain and to onboard new staff into. All right, well, we've made it back home, so let's go inside and check out some examples of where we use MDX on our actual documentation sites. Come on in.
All right, so we're back at the computer. Let's take a look at a couple of the ways that we actually use MDX components in our documentation websites. I want to start with the tabs component, which is one that's used very frequently throughout all of our websites. The way that this component works is pretty straightforward, and as you would expect, you can click through the tabs and it shows different content underneath them. So I want to go through a few examples of how this looks on our websites, but before I do so, I just want to mention this interface since it might come up a few times. This is part of a project that's called SwingSet. We're building it out as an open source project here at HashiCorp, and the best way I can explain it is it's kind of a storybook but made specifically for Next.js. We're really excited about it. It's really cool, but it's not exactly production ready quite yet. And so maybe this could be a topic for a future conference talk, hopefully. But it's got a live code editor, and it's a really helpful tool for us in developing components. All right, that's enough about SwingSet. Let's go back to examples of tabs. Here we are on the Console Docs website, And you can see here that there is that exact same component right here used to switch between different code examples, and here used to switch between different configuration examples. Tabs component is used all the time throughout our docs websites and is a really helpful tool for our docs authors to compress content and not make pages stretch out longer and longer, having users read through things that they don't really care about if that's not the option they're after. Here's another example. This one's on HashiCorp.com. I highlight this specifically because HashiCorp.com doesn't actually use MDX at all. It's just a normal Next.js website that's used as our main company website and marketing page. But still, we use the exact same component, and you can see it here used to toggle between different types of partners. It's really valuable for us to be able to use the same components that we use on all of our non-MDX websites also in MDX, because then we can kind of share the same code base and not have to repeat ourselves. Here's another example, a little more creative and with a dark theme on HashiCorp.com. This one toggles between timelines of company milestones and product release milestones. And my final tabs example is on HashiCorp Learn, which we mentioned briefly earlier. This one is interesting because you can see that there are two sets of tabs right here on this page, and when I click over to the second tab here, it syncs with this other tab group. This tab sync feature is really valuable in certain styles of documentation and would be an absolute nightmare to build out if we didn't have React components or React context available. Since we do, it was trivial to implement and provides a really useful chunk of functionality for our users. That's enough about tabs. Let's move on to another example. Another component that we use all the time in our docs websites is the code block component. Of course, for technical documentation, it's very frequent that you need to show blocks of highlighted code, showing samples of how you would actually use the products. Why I want to mention this specific one is because of its usage. You might have noticed for the tabs component, its usage was pretty straightforward and what you'd expect. You pull out the tabs component like you would in any React app and you write it down. However, for the code block, you can see that the usage is simply by using a fenced code block in Markdown, and it still renders our custom component. This is enabled by a really cool feature of MDX where you can actually set up custom configurations to override default HTML elements with custom React components. And I want to show you exactly how we configure that for our websites. We're diving deep into the core of our code, so don't worry about understanding all of this because it's a bit out of context. But the important part is that you can see this MDX provider here. If you've used MDX before, you might recognize this. If not, it's just a provider that you can wrap around your MDX content, and it allows you to set up certain configuration options. Here we pass in a components prop. The expected value is an object that has a key of the name of a component and as the value, the actual function that is the component. And it makes those components all available to your MDX content for use. Here you can see the value that we end up passing into that. Tabs and tab are familiar options that we just talked through recently. We can pass by this one. And then I want to look at these three, which are generated by this code block primitives function. We'll be seeing the way that code block config and code tabs are used over the next couple minutes, but pre really stands out among these other options. These all look like the names of React components. They're capitalized. However, pre is all lowercase, and it is also the name of a default HTML element. If you pass the name of a default HTML element to the components configuration in an MDX provider, it will actually override that default HTML element in the output with your custom component. So what we've done here, although you can't directly see it, is set it up so that pre-renders our custom code block component. That way, when authors simply put in a fenced code block, they will get, as a result, our enhanced custom component, which is really cool. I want to show off a couple other cool pieces of functionality that are part of this component. In addition to the base functionality with fenced code blocks, we have extended this such that if you add this code block config component wrapper around it, you can add additional functionality without interrupting the base syntax of Markdown or making any changes to it. In this case, you can see that line numbers will add numbering to the left. You can also highlight specific lines. You can see 3 and 5 are highlighted and the rest are grayed out, which is pretty helpful in certain longer code examples. You can add headings or file names to code blocks. which can really be helpful context as well. This is also a really cool feature. If you use the code tabs wrapper around two different code blocks, it will separate them into tabs so you can toggle between different languages. This feature can also be used with the code block config wrapper in order to combine features from both of them. And finally, you can also add a dark or a light theme, and these themes can also be combined with all of the enhanced features as well as the tabs, which is really great and makes for a super powerful and flexible code block component for our docs authors to make things nice and clear for users. Let's move on. I want to look at a couple other components. So this component is our hands-on lab component. This shows up on HashiCorp Learn, and when you click on it, you can see it opens this portal with a hands-on lab from a company called Instruct. I'm not going to go into this as it takes a minute or two to provision and set up, but you can see that this can be sized up and down as you read through the guide, and it can be hidden from the same button that you showed it from, or at any other point in the tutorial, it can be showed or hidden through a consistent UI panel. This is again one of those things that's made trivially easy with React, but would be very difficult if it was a custom extension to Markdown. So we're really grateful that we can do this so easily with MDX. And it provides a ton of value to our users who are able, in this case, to actually open up an environment where they can use and tinker around with console live as part of the docs. Last one I want to show is this Sentinel playground. Sentinel is a policy language for HashiCorp tools that allows you to control who and when and how people can make changes to your configuration. The Sentinel team built this Sentinel playground that lets you run and evaluate Sentinel code and live edit and make changes to it, which is another really powerful interactive tool for the documentation. Not only can you read about how it's used, you can actually use it in line and see how the results are, which is much more of a powerful learning tool. I've covered a lot of components. There are plenty more, but we don't have forever. So I want to move on to how we actually consume MDX. We talked about how we use components, but the way that the MDX actually gets rendered into our docs is another interesting part of our stack. We built an open source plugin called next-mdx-remote that you might want to check out if you're interested in using MDX. I want to show a quick example of how this works, and we'll just go down to the main example. What's interesting about MDX Remote is that it runs out of get static props. It doesn't rely on anything being in the local file system. So here you can see we set up an example source as a string, but this could also easily be replaced with an awaited function that calls to an API or reads from a database or whatever other data source you might have. You don't need your Markdown content to be local to your website. They can be split up, and this is very powerful, as we'll see in a few minutes. You can pass this source to a serialized function, return it through getStaticProps, and consume it in your component into this MDX remote component, which will render it for you. And of course, you can pass custom sets of components that are available for use in your source. We'll get back to how this is relevant in a minute, but I want to move on to the last part of this talk's title, which is MDX documentation at scale. We've already covered the fact that we render thousands of Markdown files through all these websites and get several million views a month, so that speaks something to the scalability. But there's another project that we're working on now and we're really excited about that's going to take this to a whole different level. And this project is adding versioning capability to our documentation. This may not seem unique or interesting or difficult, but we've really taken it to a whole different level and absolutely made no compromises on the developer experience or the user experience on this feature, and especially not the scalability and longevity. So I want to talk a little bit about how we've set up this structure, and hopefully this will be interesting for you all. Basically, if you are a product developer working on one of HashiCorp's products, you might get to the point where you're ready to cut a new release. When you push that release tag to GitHub, we have two things that happen. On one branch, we will pick that up and run a normal deployment through to Vercel. And on the other hand, we have a custom GitHub action that looks at the MDX files that are actively in the repo at the time of the release and syncs those files' contents into a database, associating them with the release tag that was pushed. Now, when the website needs to build a page, it can use MDX Remote inside of getStaticProps to go to the database and ask for the right version of the docs from the files that they need. in the database and render the content, which is great. Perceptive viewers might be asking themselves at this point, why do you need a database at all? Why couldn't you just go to the file system to get the docs? And the answer is mostly around the bloat that is introduced by versioning. If you want to be able to render 10, 50, 100 past versions of your product's documentation, and you want to be able to use the file system at deployment, all of those files must be available in the repo at the time that you deploy. So that means you're storing hundreds and hundreds and hundreds of copies of nearly identical markdown documents, in addition to all of the embedded images, videos, and anything else that are part of your docs in your repo. Over time, that ends up being a very bloated, big, slow, and difficult to work with Git repo. On the same note, this thing would also happen to your deploy times. So as you add more and more and more versions to your docs, your deploy times would get slower and slower and slower because you need to render more and more and more content in order to get your site out the door. Our scientists and analysts did a study of the effects of what would happen if we were to implement this type of infrastructure and came out with this result. If you build all versions every time that you release your doc site, you'll end up with a seriously large chungus worth of a deploy time and a chungus worth of a GitHub repo. And nobody wants that. So we needed to figure out a better way to do this. And the database was largely the key to doing that. What we've done effectively is made it so that on the current version of the docs, it will pull the content directly and render all of those as static. However, for any older version of the docs, we leverage Next.js's ISR feature to dynamically render the page based off of the version tag that's necessary, pulled from the docs database. This way, our Git repo just works exactly as intended. It only has the current version of the docs, and if you want to see old versions in the Git repo, you can go check out older tags. It's the same way with our deployments. It only deploys the current version of the docs, and our build time stays fast and constant over time, even as we continuously add versions. And yet, users are still always able to access docs for any version that they need, leveraging the power of ISR. This split between the docs content and the rendering functionality also enables a really interesting optimization for us. I mentioned earlier when we were outside that our product authors like to make changes to the product code and then also make changes to the documentation as part of the same pull request. This is a nice workflow for them that makes perfect sense. But if your files and your website are bound together in the same place because you rely on the file system in order to render it, this means that your website needs to live in the repository for your product code. This creates a lot of difficulties since the website structure is effectively a different project, and so you have pull requests flowing in for making performance optimizations to the website in the same place that pull requests are coming in for making changes to the actual product code, which is written in a completely different language. Separating these out to two different places has a lot of benefits and helps to clean things up and retain a lot of sanity, and we're easily able to do that using MDX-remote and our content sync scheme. So now we can keep just the markdown files in the product repos, and product authors can still use the same workflow to update them, whereas we can pull out all of the logic for actually building the website and all the JavaScript and TypeScript pages into a separate repository that the web development team can work on when they need to make changes to the structure of the website. There's a lot more here to talk about. We've only scratched the surface of this structure. For example, we have frameworks set up that will transform our content if we make breaking changes to any of our components, or if there are breaking changes that come into MDX, so that older versions are no longer compatible, I should say, with the current website. We have workflows set up for how product authors can make changes to older versions of the docs if they notice a typo or something they need to adjust, and there's tons more. We're super happy to talk about it. We're loving this project. It's super interesting for us, and so feel free to reach out and ask about it, and we're happy to chat. If you're watching this live at the conference, we'll be in the Discord answering questions. All right, well, I think we've gone deep enough into the weeds for now. Let's wrap this up, and we'll go back outside to do so.
you're thinking about building a documentation site that needs to scale up over time, Next.js and MDX are great choices. You get a ton of flexibility extending Markdown's native capabilities and a nice clean interface for your developers and authors using MDX. Oh, hi. And with ISR from Next.js, you can easily scale up your content no matter how much it grows or how many versions you need to support. These tools make my team feel confident that we'll have a stable foundation for our docs for the company's growth for many years to come. That's pretty much all I had, so thanks for tuning in. Before I go, a couple of shameless plugs. First of all, if this type of problem seems interesting to you, we are hiring at HashiCorp, so feel free to reach out. And second, if you enjoyed this lovely scenery, check out Serenbe, the little town I live in outside of Atlanta. We could always use more nice and friendly people here. Thanks for tuning in, and enjoy the rest of the conference. Bye.